Hi, this is Mr. Max with the sixth question on my series of the applications of differentiation. So you have got a diagram here. It shows part of a curve. So you can see the curve is there. And the equation of the curve is y equals to the square root of 3x plus 1. And then you have the point P, which is the point 0, 1, and point Q, which is right up there, which is the point 1, 2. And they are on the curve. Tangents are drawn to the curve at the points P and Q. So you can imagine if you draw a tangent there and you draw a tangent there, you have to find the acute angle in degrees, correct to one decimal place, between the two tangents. Okay, so first of all, we need to be able to differentiate this, but let me just rewrite this as the quantity 3x plus 1 all raised to the power of a half. Okay, and then I'm going to say let u equals to 3x plus 1. And du dx is going to be 3. Okay, all right, and then something else, y then will equal to u raised to the power of a half, and dy du will equals to a half u raised to the negative half power. Okay, so if I have to continue, I find dy dx is going to be du dx multiplied by dy du using the chain rule. So that means du dx, which was 3, I'm going to multiply that by dy du, which is a half, negative a half power. But remember, my u was nothing but 3x plus 1. So I'm nearly done. I'm just going to clean this up a little bit. If you see, this is becoming 3 over 2, and then I have got times, that is going to be 1 over the root of 3x plus 1. Notice if you rewrite that. So to clean that up, I'm going to have finally as 3 over 2 root 3x plus 1. Okay, so this is dy dx. Now I have my gradient. Okay, this is my gradient. Maybe I should just write it correctly nicely so that it can make a little bit more sense. So it's 3 over 2, then it's 3x plus 1. So this one here is my gradient formula, or simply my gradient. Okay, so the objective here is, now I've got 2 points. I have the point P and I have the point Q, and I can find the gradients of the x values at those points. Okay, so my point P, so if I just want to create a little bit of my point P and my point Q. So P is 0, 1, that is 1, 2. So if you know the x value and the y value, okay, point Q is 1, 2 and 0, 1 for P. 1, 2 and 0, 1. Okay, so let us just write our derivative formula again. Dy dx is equal to 3 over 2. Then this was 3x plus 1. Okay, so I've got a gradient here, and this is where perhaps this is going to count. Just want to bring my point P, okay? And you can maybe say, given what a gradient of tangent, okay, at point P, which was the point, let's just write it nicely, at point P, which is one right up here, 0, 1. So that is going to give me the gradient. If I substitute it into my formula, it's going to give me 2, and then it's 3 times 0 plus 1. So the gradient will be, when x is equal to 0, the gradient will be, well, you have got 3 over 2. Okay, so if that is the gradient, then the tangent, because tangent is an angle of 3 over 2, so the angle, therefore, okay, let's just get that correct. The angle will be the inverse tangent of 3 over 2. So what will be that angle that is formed by that? Okay, so just get you the idea. So it is like that particular tangent, maybe you'll have another particular tangent, just the way it's drawn. The angle that they are referring to, that we are supposed to calculate, the angle that we're supposed to find is this little angle here. That's the angle that we are supposed to find. Okay, that is formed by these tangents. All right, so we're first going to find the angle here. So we're going to say, well, this angle here is going to be, well, you grab your calculator, make sure your calculator is in degree mode. So we also have the inverse tangent, shift inverse tangent of 1.5 or 3 over 2. So that angle is 56.3, 3 degrees, 1 decimal place. All right, so that is 1. So what is going to be the gradient of tangent at point Q, which is 1, 2? So substituting that into our equation, our gradient formula, that's 3, where we know that here the value of x is nothing but 1. Well, if you substitute that in, you get 3 over 2 times square root of 4, that's 2, so that will be 3 over 4. Okay, so again, you can go ahead and say, well, tangent of that angle, 3 over 4, that angle will be the inverse tangent of 3 over 4. Okay, and when we grab our calculator and make sure that we can find that. Okay, so let's go back. That angle is 3 over 4. That's 36.9, 36.1 degrees. So that angle is 36.9 degrees. Right. So in order for you to find what we are looking for, we are saying, let's say, what will that particular angle be there? Okay. So if I have to find that angle, the angle, and this is how the acute angle, okay, between the two tangents, okay, my handwriting is terrible, will be 56.3 minus 36.9 degrees. Okay, so it will be 56.3 minus 36.9. It's about 19.4. 19.4 is correct. Okay. All right. So just to show you what I mean, I have done this little problem using some of the software that I have. All right. So let's say that's how that particular function would be. So that was the function y equals to square root of 3x plus 1. Okay, right. So if I'm going to draw the tangent, let me bring the point first, point A. So point A is that point there. Point B is that point there. Okay, right. So I hope that you still know how to draw the tangent of such point. All right, because from our previous work, if we know that the gradient is equal to something, we should be able to draw the tangents. Okay, I can draw the tangent. Is y-intercept is going to be 1 here. The gradient was 1.5. And if I draw the other one, I can find its y-intercept. But anyway, I've done that. The gradient was 3/4. Okay, so what we are interested in was this particular angle here. So I'm just going to bring in one more point, C, where they intersect, and one more point, D. And I brought that point up because it's going to help me to be able to do that particular, to find this angle. So this is the angle that I'm looking for. Right? So the green one represents the curve, that one is the tangent, and the other one is the tangent. This is the angle that I'm referring to. All right, and in order to find that angle there, that is the particular angle, that 19.4 that we are looking at. Okay, all right. So anyway, you're not asked to sketch this curve. You're simply asked to be able to determine those values by finding the angles and then subtracting the two angles from each other, because you are looking for the acute angle. Remember, the question asks you to find the acute angle. It's about worth 4 marks. All right, the acute angle to 1 decimal place. Okay, so that's how this little question is done. And again, step by step. Remember, when you are actually differentiating a curve, you are actually finding its derivative, which is its gradient. So if you have the x values of the 2 points that you're given, then you can substitute those x values to find what is the gradient when x equals to 0, for example, at point 0, at point P, and what is the gradient when x equals to 1. Once you have determined what the gradients are, okay, then you can differentiate. I mean, then you can substitute. You have got the gradient here, and then you can find the angle, and also then you find the gradient here. And after substituting the x value, then you can find the two angles, and the acute angle would be the difference between those two angles.